Ever wonder how the solar system came to be? Picture this. Billions of years ago, a massive cloud of gas and dust was just floating in space, seemingly calm. But then, something extraordinary happened. A collapse that changed everything. What could have caused this cosmic event? And how did this chaotic beginning lead to the formation of our Sun, Earth, and the other planets we know today? In the next few minutes, you'll discover the incredible story behind the solar system's formation, from the mysterious nebula collapse to the birth of planets. By the end of this video, you'll have a clearer understanding of how our cosmic neighborhood came into existence. So, buckle up and get ready for a journey back in time, to the very origins of everything we see around us today. Don't forget to subscribe to Small World, and let's embark on this astronomical adventure. Imagine, billions of years ago, a vast, cold cloud of gas and dust floated through space, unbothered and seemingly eternal. This giant molecular cloud was the origin of the solar system, a birthplace that few could have foreseen. However, something monumental occurred. Likely the shockwave from a nearby supernova, this disturbance set off a chain reaction, leading to the nebula collapse, a process that would forever change the cosmos. Picture this event like a domino effect. Once one piece falls, everything starts to unravel. But what exactly triggered this collapse? Could it have been a one-time cosmic accident? Or is this how every star system begins? As the nebula started to collapse under its own gravity, it began to spin faster, much like a figure skater pulling in their arms to increase their spin. This rotational force flattened the cloud into a disk, with most of the mass concentrating in the center. The rest of the material formed a swirling, chaotic disk surrounding this central mass. The collapse was not smooth or predictable. It was turbulent, full of twists and turns that shaped the future of the solar system. But here's the kicker. What if the collapse had been different? What if the forces at play had created a solar system unlike the one we know today? This initial collapse set the stage for everything that came after, but it left us with more questions than answers. What unseen forces were at work during this chaotic event? Could other factors have influenced the way our solar system formed? As we move forward, the birth of the Sun is the next critical chapter in this cosmic tale, a story that continues to unfold with each new discovery in space science. At the center of this swirling, collapsing nebula, something incredible was happening. A star was being born. As more and more material fell into the center of the disk, it began to heat up, forming what scientists call a protostar. Imagine this as the seed of our Sun, slowly growing, gathering strength. Eventually, the pressure and temperature became so intense that nuclear fusion ignited. This was the moment the Sun truly came to life, a powerhouse of energy that would dominate the solar system. But here's a question. What if nuclear fusion hadn't occurred? How different would our tiny corner of the universe be? The Sun's early years were marked by chaos and mystery. For millions of years, it wasn't the stable star we see today. It was a young, fiery entity, constantly battling to maintain equilibrium. During this time, powerful solar winds swept through the surrounding disk, blowing away lighter elements and shaping the environment around it. The Sun's energy was relentless, but it was also the force that allowed planets to begin forming. Yet, even with all this power, there are still mysteries surrounding the Sun's formation. What secrets might this star still hold about the origin of the solar system? The birth of the Sun was not just a turning point. It was the beginning of everything we know. Its formation dictated the structure of the solar system, influencing which planets would form and where. But the Sun's story is far from over. As we continue to explore the vastness of space, new discoveries could reveal even more about how this star shaped our cosmic neighborhood. Next up, we delve into how this newfound Sun influenced the creation of the planets, setting the stage for the solar system as we know it today. With the Sun blazing at the center, the leftover material in the rotating disk began to coalesce, forming the building blocks of planets. These small chunks, known as planetesimals, collided and merged, gradually growing into larger bodies. The inner regions of the disk, where temperatures were scorching, gave rise to rocky planets like Earth and Mars. Meanwhile, farther out, cooler conditions allowed gas giants like Jupiter and Saturn to form. It's fascinating to think about how different the solar system could be if just one of these early collisions had gone differently. What if Earth had formed closer to the Sun? Or if Jupiter had never gathered enough mass to become a gas giant? The process of planetary formation was anything but peaceful. The young solar system was a chaotic place, with countless collisions shaping the planets we know today. For instance, the Moon is believed to have formed from a massive impact between Earth and a Mars-sized body. And let's not forget about Uranus, which was likely knocked sideways by a colossal impact, giving it its unique tilt. These events highlight the randomness and violence of planetary formation. Imagine how different our world and the entire solar system might look if these early impacts had played out differently. As the planets continued to grow and clear their orbits, they shaped the solar system into the organized structure we see today. But even now, there are still mysteries about how this process unfolded. For instance, why did some planetesimals become planets while others were left as asteroids or comets? These unanswered questions keep scientists searching for clues, and every new discovery adds another piece to the puzzle. But before we dive into the latest findings, let's explore one of the most dramatic periods in the solar system's history, the Late Heavy Bombardment. Around 4 billion years ago, the solar system entered a period of intense chaos known as the Late Heavy Bombardment. During this time, the young planets were pummeled by a relentless barrage of asteroids and comets. Imagine the skies filled with fiery debris, crashing into planets and moons alike, leaving behind craters and scars that still mark their surfaces today. Earth wasn't spared. This period played a crucial role in shaping our planet, possibly even bringing water and organic materials that would later give rise to life. But what if this bombardment had been more severe? Would Earth still be the thriving world we know? The impact of this chaotic era is visible across the solar system. The Moon's surface, with its countless craters, tells the story of this violent time. Mercury and Mars also bear the marks of these ancient collisions. These impacts weren't just destructive. They helped shape the final structure of the planets, including Earth. Some theories even suggest that the Late Heavy Bombardment could have contributed to the conditions necessary for life by delivering essential compounds. It's a fascinating idea, one that makes you wonder how much of our existence is owed to these ancient cosmic events. Despite the scars left by this period, much remains unknown about the Late Heavy Bombardment. What triggered this sudden surge in impacts? Was it a rogue planet disturbing the orbits of distant objects? Or perhaps a shift in the positions of the gas giants? These questions continue to puzzle scientists, and future missions may hold the key to unlocking the mysteries of this turbulent time. But as we look back at the past, we must also look forward, because the story of the solar system is far from complete. What other secrets lie hidden in its vast reaches, waiting to be discovered? Even with all we know about the solar system, so many mysteries remain unsolved. One of the biggest questions is, how did the planets end up where they are today? Some theories suggest that giant planets like Jupiter and Saturn migrated from their original positions, dramatically reshaping the young solar system. These movements could have caused massive disruptions, ejecting smaller planets, or even creating entirely new ones. It's like a cosmic puzzle, one that scientists are still piecing together. And with every new discovery, our understanding of the solar system's formation continues to evolve. Beyond the planets, there's the enigmatic Kuiper Belt and Oort cloud, regions filled with icy bodies that lie at the very edge of the solar system. These distant realms may hold clues to the early solar system, preserving materials from its birth. But they also raise questions. Could there be a hidden planet lurking in these remote areas, influencing the orbits of distant objects? Some researchers believe that a massive, yet unseen, Planet 9 might exist far beyond Neptune, waiting to be discovered. The hunt for this mysterious planet is ongoing, and its discovery could reshape everything we thought we knew. As we look to the future, upcoming missions and advanced telescopes promise to shed light on these mysteries. Space agencies worldwide are planning ambitious journeys to explore the outer planets, asteroids, and even the Sun itself. These missions will help us uncover new details about the solar system's formation and perhaps even reveal answers to questions we haven't yet thought to ask. So, while we've come a long way in understanding the solar system, the journey of discovery is far from over. What will we learn next about our cosmic neighborhood? Only time and a bit of exploration will tell. As you've just seen, the solar system's formation is a tale of chaos, creation, and cosmic wonder. From the collapse of a giant nebula to the birth of our planets, every moment played a crucial role in shaping the universe as we know it. Now, think about this. How does knowing the origins of our solar system change the way you view the world around you? Could understanding these cosmic processes help us predict or even influence the future of our planet? If you found this journey through space fascinating, make sure to like this video, share it with your friends, and subscribe to the channel for more deep dives into the mysteries of the universe. And don't forget to hit the notification bell so you never miss out on the next mind-blowing discovery. Speaking of mysteries, did you know that red dwarf stars, one of the most common types in our galaxy, can fade away without a trace? Check out our previous video on red dwarfs, the stars that fade without a trace, to explore yet another enigma of the cosmos.